Hello everyone, I hope you liked the previous session. So in today's session, we are going to learn about light emitting diodes. What are diodes? What is the working of diode? How we can interface multiple LEDs with your Arduino board. Then we will learn about the buzzer and how we can interface the buzzer with Arduino. We will write code to generate melody with buzzer, and in the end we will learn that how we can design a circuit for alarm. So starting with LEDs first. So LED stands for light emitting diode. In the simplest terms, LED is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current combine together within the semiconductor material. Semiconductor material here means the material that is generally used for the manufacturing of your LEDs. We have many types of semiconductor materials. The most commonly used is silicon or germanium, with which our LEDs are made. Now, as you have seen in the previous slide, that LED has two legs, or you can say two terminals, and the two terminals are anode and cathode. The cathode is your negative terminal and anode is your positive terminal. Now let's see the working of your LED. When a light emitting diode has a voltage source connected with the positive side on the anode and the negative side on the cathode, current will flow, then your LED will glow. That means your LED connected in a circuit will only glow if you connect the positive terminal of the battery with the positive terminal of your LED and the negative terminal of your battery with the negative terminal of your LED. And if you invert the terminals of your LED with the terminals of your battery, that means the positive of your battery is connected to the negative of LED and the negative of your battery is connected to the positive of your LED, then the LED in the circuit will not glow. So if you want your LED to work, then always you have to make it forward biased. Now you can see in the image, this is your light emitting diode, which is having positive cathode and negative anode. And there is a flag spot with which you can actually identify that which one is the anode or which one is the cathode. LED is actually used for converting the voltage into light. That means if you connect the LED in a circuit, then the battery is giving the voltage and the LED will emit the light when the voltage is passed through it. So it is a type of diode which emits light. The on state voltage of your LED is 1.2 volts to 2.0 volts. That means if you supply voltage more than 2.0 volts to your LED, then your LED will burn out or will explode. We can use LEDs at various places like automotive headlamps, or you can use your LEDs in traffic signals also, and camera flashes also use LEDs. I hope you are clear with the LED concept. Now moving to the diode. So diode is defined as a two-terminal component that conducts current in only one direction. Basically, your LED was also a two-terminal component, and diode is also a two-terminal component. An ideal diode will have zero resistance in one direction and infinite resistance in the reverse direction. Here, resistance is actually the ability of your resistor, and resistor is actually used for limiting the flow of current that is flowing through your circuit or that is flowing through your electronic components. A diode can change the alternating current to the direct current. Here, alternating current is the one that is used for your electronic appliances at your homes, like television, refrigerator, microwave ovens. These all electronic appliances work on AC. And next is direct current, that is DC. DC is the current that we obtain from the batteries or cells that are used in clocks or watches, remotes, etc. So we can use diode as an inverter because it is converting one type of current, that is DC, into AC, into the another type. Now is the diode symbol. You can see in the image attached that the above is the symbol that we use for denoting the diode, and the image below the symbol is actually the diode which we use in real time. So the in the symbol, the arrowhead points in the direction of conventional current flow in the forward biased condition. It means that in case of diode, we connect the anode, that is positive terminal, to the P side, and cathode, that is negative terminal, to the N side. In LED also we have positive and negative terminal named as anode and cathode. Similarly in diode also we have positive and negative terminals, plus and minus. Now we will learn that how we can make LED wave circuit with our Arduino. So this is the circuit diagram in which we have used 6 LEDs along with 6 resistors, and all these LEDs and resistors, positive and negative, is connected to the Arduino board. Here what we have done in the circuit is the positive terminal of your LEDs, that is the anode, is connected to the resistor, and the second end of your resistor is connected to the Arduino board digital pins. Pin number 2 to 7 we have used, and the negative terminal of your LEDs, that is the cathode terminal, we have made common, and then we have connected all the cathodes of your LEDs to the ground of your Arduino board. I hope the circuit is clear and the connections are understood. Now moving to the programming. The Arduino programming is done on the Arduino IDE software, and we have predefined commands for that. So starting with the programming of a LED wave, the programs in the Arduino software always starts with void setup. So in void setup we have written pin mode 2 comma output, pin mode 3 comma output, till pin mode 7 comma output. These commands actually indicates that we have used pin number 2 to pin number 7 of your Arduino board, that are the digital pins. These pins we have used for connecting the LEDs of your uh, circuit. And output means that we are using the LEDs as the output. Next is void loop, in which we have used digital write to comma high delay 1000, digital write to comma low, then delay 1000, and so on. And these commands are for all the LEDs starting from pin number 2 to pin number 7. Here digital write to comma high means that the LED connected to your pin number 2 will remain on for 1 second, as the delay is 1000 here. So 1000 here indicates 1 second, and then it will turn off as we have used the command digital write to comma low, and it will be off for 1 second as delay is 1000 here also, and this thing will continue for all the LEDs we have used in the circuit. So basically in void setup, the commands that we use are run once only. when we turned on our Arduino, and the commands that we use in void loop are used for the repetition. That means these commands will run again and again. So this is the continuation of your previous slide in which we have completed our program. So I hope it is clear. Now moving to our next topic, that is buzzer. So buzzer is basically an audio signaling device which produces a beep sound. You can see the images of buzzers on the right side, and in the buzzer also we have two terminals, as you can see, positive and negative. So typically uses of buzzers include alarm devices, timers, etc. So that means you can use buzzers where you want alarmed about something. You can use buzzers in communication equipments, automobile electronics, portable equipments due to its compact size. That means the size of buzzer is very small. So you can use buzzers in the devices which you want to take with you anywhere. Now this is your interfacing of buzzer with the Arduino, in which there you can see the buzzer having two terminals, positive and negative. Positive is the red wire and negative is the black wire, and we have connected a resistor with the positive leg of your buzzer, and the second terminal of your resistor is going to the pin number 9 of your Arduino, and the negative of your buzzer is going to the ground of your Arduino board. And here we are using 5 volts of the supply which is in the Arduino board. I hope the connections are clear. Now we will make a program so that we can generate melody. That means your buzzer should beep whenever we turn on your circuit. So in void setup, we have written pin mode 9, output. That means we have used the pin number 9 of your Arduino for connecting the buzzer to it, and we are using the buzzer as an output. And in void loop, we have written digital write 9, high, delete 1000, digital write 9, low, delete 1000. That means your buzzer will beep for 1 second and it will turn off for 1 second, and this process will continue again and again as we have used digital write commands in your void loop. This will be the only working of your buzzer interfacing with Arduino, in which it will beep again and again. Now coming to the circuit design for alarm. Previously we have seen that how we can interface your buzzer and LED to the Arduino board individually, but now we will design a circuit in which LED and buzzer both are used in the same circuit. So what we have done in the circuit is the positive terminal of your LED, that is anode, is connected to the fourth pin of your Arduino, and the positive terminal of your buzzer is connected to the fifth pin of your Arduino. And we have connected here resistor to the negative terminal of your LED. So here you have to make a point that you can connect the resistor either to the positive terminal of your LED or negative terminal of your LED, because it is not going to make any difference. So the other end of your resistor is going to the ground, and similarly for the buzzer also the negative terminal is going to the ground of your Arduino. I hope the connections are clear. Now moving to the program. So here in the program we have used pin mode 4, output, pin mode 5, output. These two commands actually indicates that the buzzer and the LED we have connected to pin number 4 and 5, and we are using both these components as the output. Now in the void loop we have written digital write 4, high, digital write 5, high, and delete 1000, digital write 4, low, digital write 5, low, delete 1000. That means Your buzzer and LED will go high first. That means they both will be turned on at the same time. And with a delay of 1 second, they will turn off. That means buzzer and LED will turn on for 1 second. Buzzer and LED both will turn off for 1 second. And this process will continue again and again. So I hope the concepts for the programming are clear with you, that why void setup is used, why void loop is used, what is the difference between the two, and what is pin mode command, and what is digital write and delay 1000. I hope you loved the session. So thank you so much.